Where the planning and locating phases are done right, it undoubtedly minimises the dangers for those doing the actual digging. But it's this phase of the work when operatives are most at risk.
We keep referring to the importance of work orders and permits, but when it comes to actually breaking the ground, they provide essential information on the safe methods to be employed. Burns are the main injuries sustained from strikes to electrical cables, or from the explosion or fire that can occur after striking pipes containing gas or flammable liquids. Wearing the correct level of personal protective clothing can prevent or at least greatly reduce the severity of any burns. Having said this, PPE is no substitute for adopting safe digging practice. After detection devices have been used and the surface marked up, it's still important to proceed with caution. Insulated tools, preferably with curved edges, should be used to hand dig trial holes. A mistake often made is that when a cable or pipe shown on a drawing isn't found, the assumption is made that there isn't one there.
I'd say that's a big mistake. These drawings are simply a guide. The use of the CAT is simply a guide. When excavating and digging trial holes, always expect the unexpected. That way, when we do find something we weren't expecting, we're on our guard.
Detection devices should continue to be used as excavation proceeds. Digging trial holes and excavation provide another opportunity to feed back errors or omissions on drawings, or, equally important, to confirm their accuracy. Many companies now encourage operatives to mark up and note drawings accordingly. Utilities often have to be exposed so that they can be worked upon, but a lot of excavation takes place for construction and maintenance purposes, where exposing utilities unnecessarily would simply increase cost, risk and environmental disturbance. The aim here is to ensure that digging doesn't impact on any buried utilities in the immediate vicinity. Risk assessment will have specified a suitable safety margin, but a cautious approach is always required. Where power tools need to be used to break the surface, this must be a minimum of ½ metre from the marked line of any utility. Because of the difficulty of confirming depth, power tools should not be used directly over a surface, unless it has already been exposed by digging out, and a clear gap of at least 300 millimetres can be maintained at all times between the tool and the surface. Even after trial holes have been dug and the presence of utilities proved, or otherwise, the use of mechanical excavation must proceed with caution. Others working in the area should be kept well clear, and the use of a banksman is essential. Effort should be made to excavate alongside a surface rather than directly above it, digging horizontally to finally expose the pipe or cable. After the expected surface is exposed, digging should continue with care. There may be others sited adjacent or below. Where appropriate, new technology can be deployed to reduce some of the risks associated with more traditional methods. Equipment like air picks and vacuum excavation may make the job safer, but this doesn't mean the basic principles of safe working practice are any less important. Electricity cables are normally laid in a trench between 45 centimetres and a metre deep. Some high voltage cables will be deeper. Mains gas is normally buried in roadways at about 75 centimetres and footways at about 65 centimetres. Service connections are at about 45 centimetres in both. High pressure gas is usually buried with at least 90 centimetres cover. But these depths are purely a guide and should never be assumed. Street lighting cable is often much shallower and looped well away from the most direct route. Exposed cables or pipes must be protected from damage. They may need supporting and should never be walked on. Any damage to a cable or pipe coating must be reported. Even if there's no immediate danger, it could pose a risk at some later date. No attempt should be made at repairs or trying to disguise the damage. And it should go without saying that no attempt should ever be made to move an exposed service. Permits and drawings should have specified the type of utility expected to be found, but those doing the work should be able to visually identify them. Failure to be able to do this has been a common cause of accidents. A wide variety of materials and colours have been used over the years. For modern installations, a national colour coding system for buried services has been agreed by most utilities. It's important that this isn't confused with the one that applies generally for above-ground building and process services. It should also be remembered that old non-utility services or other pipelines may not conform to this standard. By the very nature of the environment, they won't be in the same pristine condition as when first laid, and colours often don't look the same under different lighting conditions. Equal care should be taken with reinstatement. The correct marking must be applied where necessary and the appropriate backfill materials used. Materials like flint or brick can have sharp edges that can easily damage a pipe or cable once weight is applied.
Clever design and new technology may gradually reduce the need to excavate. But with an infrastructure dating back centuries, there'll be a need to employ traditional methods for some considerable time to come. And it doesn't matter whether it's a big company working on a major project or a small contractor doing minor works. If all parties play their part, we can drastically reduce the number of utility strikes that currently occur and save the cost, disruption, and more importantly, the misery that they often cause.